So from the University of the Philippines, Diliman, help me welcome Mr. Leonard Jello E. Gallinato as he presents their work entitled Site Stability Analysis for a Solar Power Plant in Mindoro Island using GIS.
Good day, everyone. We, Leonard Gallinato, John Elisa Natividad, K.P.L. Satera, and Swin, incoming third-year students of Bachelor of Science in Geodetic Engineering of UP Diliman, proudly presents to you our project named Site Suitability Analysis for a Solar Farm in Mindoro Island using Geographic Information System. So without further ado, let us dive into the realm of identifying the most suitable areas for solar power plants, a journey that not only embodies technological advancement but also echoes our commitment to a more sustainable world. First, why Mindoro? The primary reason is that the duration of the power outages surpasses the duration of electricity availability. This could be due to various factors such as inadequate supply or high demand that the current electricity system cannot meet effectively. Moving forward, let's consider the rationale behind opting for solar power plants. In addition to their renewable nature and minimal maintenance requirements, certain studies have demonstrated that in the context of the Philippines, solar power generation exhibits a projected potential of producing approximately 4.5 to 5.5 kilowatt hour per square meter per day. This capacity is significant enough to provide a favorable environment for the successful operation of a solar power plant. And lastly, for the objectives. This project aims to assess land use and topographic data, evaluate proximity of potential sites to existing infrastructure or power grids, and identify areas with high solar irradiance within the region, specifically to identify suitable plant sites in Mindoro Oriental and Occidental using geospatial analysis.
Here are the exclusion criteria for this project. These exclusion criteria were based from the study of Lavosada et al. From the UP Diliman Department of Mechanical Engineering about suitable sites for solar power plants in the Philippines. The exclusion criteria include protected areas, areas with slope more than 2.1%, areas with direct normal irradiance less than 1600 kilowatt hours per square meters per year, water bodies, and urban and agricultural areas. And then here are the scores per range of the included values for each criteria. Each of these also has a multiplier based on their rank or their priority, which was obtained through the analytic hierarchy process done by the said study. So here's the general flow chart of our study. To simplify, the process mainly involved doing a Boolean approach to extract the included areas based on the exclusion criteria. After extracting the suitable sites, these areas were then weighted based on the rank of the said criteria. So here were the data sets used. These were obtained from NAMRIA, Next GIS, and of course, the 2021 SWR data was obtained from Project SINAG. However, the data provided was in watts per square meter with a monthly temporal resolution, which is not consistent with the units for the criterion for analysis, thus conversion was done. And to aggregate the monthly values into an annual value, the Mosaic to New raster tool was used using the sum mosaic operator. Now for the pre-processing, this mainly involved reclassification of raster data based on the ranges of values provided in each exclusion criteria and conversion of reclassified raster data to vector, which will be further used in the main processing. And in this stage, buffering was done for the roads and waterways, but actually the highest score, which is 9, has a buffer of less than 25 kilometers and 20 kilometers for roads and water bodies respectively, which already covers the entire island of Mindoro. Hence, for these criteria, all of the areas gets the highest score. And also here we have the included areas for the irradiance and the areas excluding the protected areas, the areas with slope greater than 2.1%, and the included areas based on their land cover. So all of the resulting vectors, as observed, were areas that are included based on each criterion. This is for convenience, where getting the suitable sites would only involve the intersection of the said shape files. So the included areas based on each criteria were intersected to produce the final exclusion map. These are the areas that are suitable for the establishment of a solar power plant. But to determine as to where among these areas have higher level of suitability, weights were added as mentioned previously. These weights were per criterion were based on their priority or importance, and these basically served as a multiplier to whatever score a certain area obtained for a criterion. This was done in the field calculator. Here are the top municipalities by suitable area. We have Sablayan, Santa Cruz, and Calintaan. But what's more important are the top municipalities by contiguous suitable areas, since we are talking about building a solar power plant contained in one area only. So we have one in Rojas, one in Santa Cruz, one area in Sablayan, one in Calintaan, and one in Mamburao. And finally, the most important insight is the top contiguous areas in a municipality obtaining the highest suitability score. So um, we have one area in Rizal, Occidental Mindoro, then one in San Jose, Occidental Mindoro, and one in Bulalakaw, Oriental Mindoro. So here's our final map layout for the project. That would be all. Thank you for listening and have a great day ahead. Ganun lang kasi.